All right. Hello, STEM students. So we have a review for the test, which is tomorrow, Thursday, and it's going to be on a Kami assignment, so you can easily graph. And just please, obviously, show your work. I hope that's obvious, and no work is no credit. But here we have our first example. We have Paisley, and she has some kids, sells hamburgers for $6.50, tacos for $4. She has $80 to spend, and she has to buy a minimum of 14. Okay, so X is the amount of hamburgers, Y is the amount of tacos. You should pause this video and see if you can set up the correct system. So I know that, let's see, she has, actually, let me try equation. So she has to buy at least 14 hamburgers and tacos altogether. So this is the our first equation, our first inequality, is that the x plus the y has to be greater than or equal to 14. The second one, she only has $80 to spend, so she can, of course, spend $75 or $70. She just can't spend more than $80. So she has to spend less than $80. And that is $6.50 per hamburger. Hamburgers are X, plus $4 per taco. Tacos are Y, and that all has to be under $80. So here are our two, our two inequalities. And then we need to graph these, and they are inequalities, so we're going to shade. Starting with this top one, I'll subtract the, the X on both sides. So Y is greater than or equal to negative X plus 14. And then the second one, I would subtract 650x, 4y is less than or equal to negative 650x plus 80. And if I divide by 4, 650 divided by 4, let me get my calculator out. Is about 1.6, so negative 1.6x. And then 80 divided by 4 is 20. So I've got my two inequalities. Now I get to shade. So I go to shapes, pick a line, graph this first one, has a y-intercept of 14 and a slope of negative 1. So again, anything, this is important, anything on this ordered pair, the combination of hamburgers and tacos, there are exactly 14 items. Anything under it, there are less than 14 items. Anything above it, there are more than 14 items. And she has to buy a minimum of 14, so at least 14. So every solution for Paisley is above this line in terms of the amount of stuff she needs to buy. But there's also a money issue. She only has $80. So our y-intercept is 20 and negative 1.6. So I do my best to go down negative 1.6 and over 1. And then let me see if I can extend this line, keeping my eyes on this order pair right here. So again, from the y-intercept, go down. I'm doing my best to guess of 1.6 down and then over 1, and then just extend that. I'm not even looking where the line is ending. I'm just looking to make sure that the line goes through that point right there. And she has to stay under. The y values have to be less than this. So the everything that's above this line and less than this would be this section over here. So you would just do your best to make it as clear as possible that where your solution is. So everything, every ordered pair in here is more than 14 items, but also she will spend less than $80 in total. And we're supposed to determine one possible solution. So one possible solution in here is 412. So 412. 412 is a solution. That means that she can buy 4 hamburgers and 12 tacos. That's more than 14 items, and she will spend less than $80. And then there's another question. What does 611 mean? Well, 611 is, let's see, 611 is right there. 611 is not a solution. You see how it's above, it's more than $80. So 611, what does that mean? 611 means she bought 6 hamburgers and 11 tacos. This is more than 14 items, which she needs to do, but it is over $80. So this is not a solution because she does not have the money to do it. This problem, I think there's only 3 in total. So we've got Lily, she's working 2 jobs. She's landscaping for $9 an hour, and she's clearing tables for $15 an hour. She can only work a maximum of 11 hours, and she must earn a minimum of $120. She can work no less than 7 hours cleaning tables. So there's 3 constraints. She has to work at a most 11 hours. That's one constraint. She needs at least $120. That's a second constraint. And for clearing tables, it says no less than 7 hours cleaning tables. What does that mean? That means at least 7 hours. But remember, a total of 11 altogether. And X represents the hours landscaping. Y is the hours cleaning tables. So I've got an equation right here. All the X represents all the hours landscaping. Y represents all the hours cleaning tables. So all those hours together cannot exceed 11. So it has to be less than or equal to 11. And if we solve for X, we've got an equation right there. Another constraint is that she needs at least $120. So she gets $9 per hour of landscaping. So 9 times X plus 15 times Y. So this is all the money she makes landscaping and cleaning tables. All the money she makes altogether has to be at least 120. So her money she's making is on the left, and she wants that to be bigger than 120. Obviously, she wants to be as much as possible. Why doesn't she work 1 million hours landscaping and 1 million hours cleaning tables? Wouldn't she have a ton of money? Yeah, she would have a ton of money, but she's constrained. She can only work a maximum of 11 hours. And then for this, we'll also solve for Y. So we will subtract 9x on both sides, divide by 15. Let me get my calculator out. Negative 9 divided by 15. Oh, I can do that one. They both have a 3 in common. So 3/5 x. And 120 divided by 15 is 8. So there is our second constraint. We have a third constraint, no less than 7 hours cleaning tables or clearing tables. Well, Y represents all the hours clearing tables. So Y can't be 3. Even if she hates clearing tables. Oh, excuse me. She hates clearing tables. She has to spend no less than 7 hours clearing tables. So who knows what that means? Maybe her parents own a restaurant. So no less than 7. So all the hours she spends cleaning tables has to be at least 7. So 7 or more. But of course, less than 11. So here are our 3. I go to shapes and align. Here are our 3 constraints. And I just graph them one by one. The first one is the total hours amount constraint. She can't work more than 11 hours. So my y-intercept is 11, and the slope is -1. This is a little trick. If the slope is ever -1, the two intercepts are the same. So 11 and 11. Because if you go down 1 over 1, down 1 over 1, you'll end up at 11 for both intercepts. Only when the slope is -1. Here, the y-intercept is 8, and the slope is -3/5. So I would go down 3 over 5. And then again, down 3, and then over 5. And then I can try it again, down 3 over 5. And this is the money constraint. She wants to make at least 120. So every ordered pair on this money line would be exactly 120. Anything above it would be more than 120. On the other line, every ordered pair in here, she's working exactly 11 hours, and she has to say either on that line or underneath it. So far our solution is right in here in this triangle in the upper left. But there's one more constraint. The y has to be greater than or equal to 7. So the amount of time she spends clearing tables. Well, here's the y-axis, and here's when y equals 7. So in fact, this whole line is when y equals 7. So it has to be above this line. Now we've got this unusual quadrilateral here. Every solution in there, every ordered pair in there is a solution. Every ordered pair in here is more than 7 hours cleaning tables. It is more than $120, but it is also less than 11 hours in total. So it's asking us for another solution. Let's see, 2/8 is a solution. 2/8 is right in the middle there. So 2/8 is a solution, one out of many. This means she spends 2 hours landscaping, that was the X, and 8 hours clearing tables. I kept on saying cleaning. And she will do it. She will satisfy all 3 of her constraints. What does 8/14 mean? Well, 8/14 is way over here. It's not a solution because it's not in the shaded region. It satisfies how many constraints? 2 out of the 3. She's making a lot of money. She's making way more than 120. She's working more than 7 hours for clearing tables, but she is way past this boundary right here. This is the boundary of 11 hours in total. So 8/14 is not first of all, what does it mean? Whoops, 8/14 means she spends 8 hours landscaping and 14 hours clearing tables. This is not a solution only because she spends more than 11 hours working. That's the only reason why it's not a solution. Otherwise, everything is great. She's making more than $120. She's spending more than 7 hours clearing tables, but it's just too much time. That's 22 hours. And then our final example is to solve this by graphing. Now, if the first 2 are good for you, then this is going to be an absolute breeze. We have to solve this system by graphing. If this were solving by substitution, you would take this -x minus 5 and plug it right into y. But the directions say solve by graphing. Well, this first equation is already set up in mx plus b form, so I'm going to change this one, which means I'm going to subtract 3x. Be careful. There's this minus y right here, which is still connected to the y value. So don't drop that negative. And now divide both sides by -1. That becomes positive 3x minus 1. I think I did that correctly. Oh. Can I change the font size, make it a little bit easier to see? There we go. And now I got my 2 lines I need to graph. They're both in slope-intercept form. Let's graph them. So I go to Shapes, a line. The first one has a y-intercept of -5 and a slope of -1. Remember what I said about the slope being -1? There's that trick. The intercepts are the same, so -5 and -5. It's the same They both have the same intercept. For this class, that seems to be coming in pretty handy. But regardless, you can just start at the y-intercept and then use the slope. The slope is -1, down 1 over 1, down 1 over 1, down 1 over 1. And there is no shading here because it's exactly equal to this. It's not greater than or less than. So nothing up here works, nothing down here works. Only the ordered pairs on this line. And there's another line, 3x minus 1. So I go to my shapes, and that has a y-intercept of -1, a slope of 3. So I go up 3 over 1, up 3 over 1, up 3 over 1. And then grab the other end to extend it. And the solution is the ordered pair that satisfies both lines. And there's only one ordered pair that works for both. It is this ordered pair. It looks like -1, 4. So you would have to write -1, 4 is the solution. Good luck tomorrow on the test.